All right, we've started recording. All right, so let me, I'll just give you a few things on what we're going to do in this class. Or let's start with the recap of what we have done so far. So we've seen what Python is. We've seen how to use it in interactive mode and script mode. We've written like basic programs of Python. We've used PyCharm as an IDE. We've just touched on the basics of Jupyter, but we can actually, one of the case studies, we can do it in Jupyter, or we can start. One day I'll just use Jupyter IDE for programming instead of PyCharm. That'll give better understanding of Jupyter. And then I think we dealt with the setup. We showed you what virtual environments are and why we need virtual environments in Python. Why, like, how is it helpful as compared to like other languages? When you corrupt a file in one project, you basically, it won't affect the other projects. And you can see the virtual environments whenever you're creating new projects. When you say file, new project, and you give it a name, you can see if you click this, you will see that. That's why we use PyCharm, right? Because we don't need to like create virtual environments ourselves, but you need to understand what it is doing behind the scenes. So this is the basic interpreter it is using. It is using it from wherever you've downloaded your Python, and it creates this virtual environment here. I mean, right now it's generally abstracted out. No one really gets to see it. But if you want to change your virtual environments and stuff, we'll touch on a little bit on this when we install packages. I talk about packages. How do you install using the script? How do you install using PyCharm? We'll talk of that. And after that, we have just started with the basics of Python. We saw what we didn't do functions. We saw what variables are. Like, again, a quick recap. Python is an it's a indented language. That means there are no semicolons, and every line is considered a new thing. So mind you that the spaces you use in if-else statements are very, very important, because it's an indented based language, right? So you see that if it is basically because there are no brackets here, so the space you give between the statements is basically what you will actually use for that is what is consumed in the if statement. So let's say if you by mistake just give 3 spaces, it will not be part of the if statement. So it's, be very careful. It is based on the number of spaces, and as you go to a new line, it will consider it as a completely new thing. Whereas in case of C# and Java, you have to give semicolons to end that line. But in Python, whenever you hit a new line, it's considered as a new thing. We did that. We did some basic strings, but we did not complete the whole of strings. So we'll just I'll just touch a bit on strings. But any questions from last week or anything you guys found difficult while doing the assignments and stuff? So I'm assuming everyone did their assignments, right? 2 of you sent your code to me, and that looked good. But I would encourage everyone to finish assignments. So there's no deadline for assignments as such. You can, because I know that it is like a fast-paced course, so you can do it at your pace, but please ensure that you finish all your assignments for your understanding before the course is completed. You can do it in any order whenever you feel like, and this thing. But if you have like the first 10-15 minutes, we'll talk about if you have any questions and assignments and stuff. So this was pretty simple. The assignment which we did was basically to get you started on Python and just play with the basic strings and stuff like that. So having said that, I'm assuming since there are no more questions on this thing, so I think some of them have dropped. One second. Let me see who has dropped. I need to get used to. I think one of you has dropped out. I'm not sure who. But anyway, we will continue with the lecture. So today what we will do is we will continue with Python. Today we will do a small mini project using all the data structures which we will learn. Today we'll learn about lists, we'll learn about dictionaries, we will learn file handling, exception handling, And then I will teach a small concept which is very popularly used in cloud computing and stuff. So it's like there is a yield keyword which people generally use. We'll do an exercise with that, and combining everything, we will write a module today, which actually takes in. Uh, you need to maintain records of a certain employee structure. We'll write that with all the file handling and everything together. So that's the first 1.5 hour. I think we will play around with that. But I want to give then I'll go ahead and introduce the case study which we have. I sent a CSV file today to everyone. It's the data is from Indian liver patients. We actually got that from the Indian Health. This thing I'll spend some time on explaining what the case study is, what features are, what label data set is, and then we will move towards data visualization. So let me give you a quick a small sample of the code which we'll be writing. If you don't finish it this week, then we'll do that next week. Like for example, you will see. I think this part is like really fun because we do different visualizations and stuff like that. So you'll be able to plot these different graphs to understand how the data is distributed, which particular data to use, which particular data not to use, and stuff. So we will deal. I mean, I'll show you how plotting works in Python and stuff. But this is just to give you an idea of like the code which we will write, and then we will see a different kinds of plotting, just to make you aware that like, oh, these are the feature sets, and then why visualization is important, and what kind of graphs are out there which will help visualize data, and what kind of charting libraries and stuff like that. There is another case study. We'll do two case studies on data visualization. One is basically the Indian liver patients, and the other one is the sales data for different video game consoles collected across last 10 years. So both of them handle different problems, but we will use both of them for data engineering. So let me again repeat one thing which I think I'll repeat that every class, is the first part of the, like, I would say like 70% of our work is this feature engineering stuff. So unless you have good data, no matter what algorithm you use, how much ever you use deep learning, or like any complex machine learning algorithms, it is of no use unless you finish this step of feature engineering. Let me just see who actually dropped out and who is coming back. So there was someone else who dropped out. Okay, I'm not sure. Like, I think one of you has intermittent connection problems. But if you are facing any connection problems, you can like ping me separately on the chat. Anyway, so again, to start off, we will the first part of the any machine learning, this thing is feature engineering or data engineering. So for that, visualizations is the first step. So as I showed you some of these, this is just one of the graphs which you will be plotting at the end of this class, if time permits, or else we'll do it next class. But this is one of the plots. But then I'll give you another case study. I mean, it's really fun because we plot like different kinds of plots. Let me show you one more plot which we will be plotting. I'll give you another case study of the snowfall in the mountains nearby. We will do Snoqualmie Mountain and Crystal Mountain, and then I will show you like which of the plots are helpful in determining. So these are some of the charts which will help you in determining which particular mountain is really good for going skiing. So anyway, don't. I mean, we will cover each of them individually. Don't get. I just thought I'll give you like a small demo of what we'll be writing. So, and then that will be the question for you. So I'll teach you how to plot these. I'll teach you what each plot says. But then I would want you guys to work on the data and tell me like which mountain should I go skiing next weekend or something. So that is one sub problem we'll do. But these two case studies will be devoted towards data visualization. First one is Indian liver patients, the data which we have. I'll talk about it once we reach there. And the other one is the video game sales data. Both of them are real world data. It's not fabricated. I'm giving references from where I've downloaded the data at the end of the slide. So if you want to like download new data and stuff, you can go there, and they're all open source. So you can download and play around with like other data. So we will do that. But let's start off. Let's finish Python today. That's my main goal. So as I said, we'll finish off with the basic data structures, and combining all the data structures, I will let you design a small module for the mini project which we will do today. That sounds good?
Yeah.
Okay, cool. So I see there are no questions on the assignments or stuff yesterday. So again, this is a pretty hands-on this thing, because I don't want to like tell you, oh, string means this and that. I want you to like guys to like open. I will be doing that here. I mean, the slides are basically just for reference, where I'll come back, but most of it is basically going to be like I'll write the code. And this thing, I know some of you might be like, coding, you might not have done for a long time. If you are able to like code it in the class, it's fine. Or else when I send my code to you guys, I would want you to like at least run through the code, and then we will uh, and then you will have a feel of like, oh, how to, let's say in the future, right? Even if you're a manager and you're like managing a team, and you will understand like when they give you the code, at least you'll understand what they've used and how it is. So let's start with today's class. So yes, last week we just saw the basic of strings. There's one thing which we didn't cover is string formatting, right? Like whenever you want to print out something, like whenever you print statement is, as you have seen, is very useful. Very useful for debugging also. But there are two ways you can actually put, like it's like console.writeline in C# and uh, you know Java uses what println, system.println. So you basically can pass in parameters into your statement, and the way you do it is by giving the statement. There is a dot format function in print, which actually will help you that. So there are two ways you can do it. You can actually, so let's bring up the console and just write one print statement. So one way is basically you type in some statement, and whatever your variables are, you give it like 0 and 1, and then the corresponding, so dot format, and the corresponding variables you can print, and you can pass it to your dot format function. So when I give this statement, so let me bring up my console here. Let me go back to strings. So I think I already sent you this code, but you see this line here which says print hello like 0 and student. So this is what I use for formatting. So this is generally very useful later on. So the thing is, you just print your line, and your variables will be encoded in braces, and you'll give 0 and 1 dot format, and the format will take what this 0 should have and 1 should have. So when you run this, so you can see here, I have given hello Pramea students, welcome to class 1. Because I wanted to cover it in the last class, but anyways, so you can see this line here, right? So that is what it is printing. So if you are using, so this was an old version of Python was supporting this, but the newer versions which we've installed 3.7, anything above 3.6, you can directly give your variable name. So what I mean by that is, if you go back here, so here, let's say you have you create your variable name as name equals Pramea and count equals 1. Instead of saying dot format, you can actually use print. The only thing is you need to use F here. So that is format. You see the small F before the semicolons begin. So you have to give F, and then you will say hello, and you can directly use the variable name in the parenthesis. So is this thing clear? Why don't you guys just quickly run anything, like you can say hello, like hello world, or just say like, or you use the same statement, hello number of students, or or you give hello. Okay, let's do this. You give hello, and then you print out your name and say and give dot your age, whatever your age is. So what I mean by that is, when you open up your console, you can use your strings for like Python file, because there's all of these are like, we still didn't start with functions and stuff, so it's still in the scripting mode. So you can actually just run anything. So basically you give hello, whatever your name is, and you can use both of them. If you want to use variable names, you can say, you can create your variable name with your name, or if you want to use the old format of dot format, you can do that also. So you can, what I'm saying is hello, let's say my name, your age is, and then the second variable is 1. So now what I'll do is I'll say dot format, and then I'll give you like what my name, I'll say sample, and I'll say my age. So you see there are no semicolons and stuff. So you basically just run this, and you will see, hey, is everyone able to do that?
Yeah.
Okay, cool. So that is basically how you use your print statement. There are like a lot of other string commands too. See, there are like a lot of commands, so we can't cover all of them. But the way we can do the thing which I want to impart is basically how you use these functions on a string, so that when I give you the mini project module, you will be able to look up which function suits you and call it, because they're like only on strings there are like around 300-400 functions which will help you do that. I'm not going to cover like give examples of all of them, but it's like, for example, if you want to capitalize, right, you say your string dot capitalize, that will give you that will print out the first letter as a string. If you want to replace a particular thing, you will say python dot replace y with I, then it will print out python. And if you want to know if a string is only alphabets, like in this case, Python is alpha is the function, and that will give you true. If you want to know if it's only digits, you just say is digit, and that will give you true. There's another function called split function, which exists in most of string things. Like you say split, and you give the character on which you want to split, and that will give you like 3 individual ones. Like in this case, the string actually is a comma b comma c, and I'm splitting it on comma, so you will give a, b, and c. So that's the basics of strings. I think we have covered enough of strings. Before we go further, because I know a lot of you will get stuck writing the code and stuff, so let us just quickly cover Python debugging. So like any other like IDE. It's pretty simple. You basically set up breakpoints and you inspect stuff. The way you set breakpoints is like double click on, or sorry, a single click on the site, and you will see a breakpoint there. And then you just right click and say, instead of, we were running it, right? Instead of saying run, you say debug. So when you say debug, it will go and stop there, but it will open a debug console. Like if you see here, this is your original console here, and this is a debugger console. So basically they're two different. When you're running in debug mode, it will actually open in like in the debugger console. Here you can actually go inspect your whatever string you're given, whatever, like, whatever variables you want to check. And you can see up here, like there are these icons. You can either use those icons or you can use the F commands. I generally like would use this. Like for example, step over is F8, or you can click this thing, so it'll go next. Then there is step out, step into. Like anyone who is like programmed on like any IDE, this is like pretty standard. So this will be generally helpful for you for debugging purposes and stuff. So any questions so far? Like everyone clear with debugging, or do you want to like quickly try debugging, like put a breakpoint somewhere and then say right click and say debug? If you want to stop the debugger, you actually press the stop button here, or you can do Control plus F2. So you press stop and it will stop debugging and it'll go back to the original window. Questions? Okay.
No.
If I don't hear questions, then I'll just move forward, because this still we are in the basics, right? So, but then yeah, feel free to like stop me, interrupt me if you have any questions at any point of time. A quick thing, there are edit values and watch windows, so you'll actually see that in the debugger console. Maybe I should have covered that. So you can actually edit. So the window which we saw here, right, that was basically which the variables are there, you can right click and edit those values on the fly if you feel like you want to see a different result, or if you want to debug it for different values. So that is basically our like a small quick note on debugging. But mainly there are few standard data structures in Python. Like lists is one standard data structure. So at this point, I want to tell you, like, if anyone is using arrays in Python, it is basically in a package called NumPy. So we will cover that NumPy later on, but we'll cover what Python packages are and how do you install packages in just a few minutes. But generally, Python uses lists. A list is a collection of a similar set of items when you put them in like square braces and stuff. So it basically, that's how you create a list. So you can access a list similar to how you access an array, but Python generally uses lists. But we do a lot of programming with arrays too. But then there is a library where Python has put all these arrays and matrices into one. It's called NumPy. That's the it's numbers in Python. That's short form, right? So NumPy is the package. We'll cover that package in a bit. But lists is one very common data structure in Python. It's pretty simple to create a list. Again, for a quick recap, there are no types. Like in case of like Java or C Sharp, we'll actually say, oh, this is a list of strings, so we give string parenthesis shopping list. Here it is, you don't need to, because the interpreter is smart enough to figure it out at runtime. So you say shopping list and you give like eggs, carrots, milk, cherries, etc. If you want to access a particular element, it's again zero based index. So the third element would be shopping list of 2. The way you delete an element is called del, that particular shopping list. Length of a list is len of the shopping list. Appending an element to the list is, say, append. Max value, min value is the same. Let's quickly pull up our again debugger again. So why don't we actually so when you pull up your debugger, you actually right click and say new Python file. And when you click Python file, it'll tell you, hey, what is the name? So you can create another file for lists. So let's do a quick small example in this thing. So I have some code here, but refer to the code only when you are stuck, because it's very easy to like, just the idea is like you program it first. If you're not able to like program, then we will then you can refer to my code. So the thing which we will do here is pretty simple. You'll create a shopping list in which you will have you will include your major shopping list items. You need not actually have my items. Add 5 elements to that shopping list and print them using the format function which I just showed you. So let's quickly do that, and then we will do like a couple of examples after that. So you create a shopping list, and then remember I actually showed you like how do we use dot format and print it. So just print it out, and then we will go further and say how do you access elements in the list and stuff. So just a quick question: how many of you are actually doing the work hands-on? Like, I'm expecting everyone is actually programming along with me. Is there anyone who's not programming and is just following the class? That's fine too. Just let me know, because I will know how much time to wait then, because then I won't like.
Yeah, I haven't coded in a while, Sanket.
Okay, that's Raghav. No. Who
It, it was Jatin.
Oh, Jatin. Okay, so you're just following my command prompt, right?
Yes.
Okay, that's fine too, because again, at the end of this thing, like, people who want to like program can program, but the idea is to basically understand the concepts and this thing. So you can see my live code also. So if you are not, but I would highly encourage everyone to like write the code, because it's also fun to learn a new language if you like programming. So I'm assuming everyone else is coding, right? So let me know when you finish off this thing. So I won't. So the thing is, you create a list and just print it out for now. And once you do that, so don't wait. Like there are a lot of things you can do by yourself also. Like for example, the next step would be to print out one particular element, like print out the index in the third element and delete the fourth element and append one element to the list. So it's all very simple commands. So your commands are pretty much these. So how do you create a list again? So you say some again. Number one, you don't have the type. You just say whatever shopping list or anything, and you add elements to it like this. How do you access an element? It's a zero-based index. So you basically say shopping list of 2 or 3 or something. You will access an element. But before accessing an element, I want you to print out the entire list. So you use the command which I showed you before, like print the name and then give you the variables and then you print out the thing. You delete a particular element in it and you append a particular element. This is just practice for you because this will help you when I give you like a small mini project. Uh, so once you're comfortable with list, I will go ahead with dictionary and we will then do file handling and exception handling. Then I'll talk. So yeah, so today's thing in the first 1.5 hours, I wanted to cover, uh, the basics, like finish off with the basics of Python. We'll do some file handling. We'll do functions. How do you call functions? And mainly, I'll actually try to see if we can do. And I'll talk about the yield keyword. It is very useful when you're dealing with the large data sets. It's like most programs which run on the cloud use yield because it removes your memory constraint and stuff. We will do so. All this will be embedded in this mini project which we will write today. So at the end of the day, you will like use a list. You will use a dictionary. You'll use file handling. You'll use exception handling, and then make a small project. So that is the goal at the end of the day. Any questions on the list so far? Is everyone done with the printing of the list? So if you have any questions or like if you're not able to follow, please don't look at the code unless you are stuck because I mean, initially you need to like know the syntax and stuff. I know it's a new language. It'll take some time to get accustomed to it. But even if you are looking at the code, that's totally fine. But understand every point. Like, okay, what am I doing here? I'm actually printing out a line and here is my variable name and I'm giving dot format shopping list. Okay, now if I'm actually, then if I want to print out a particular element, how am I accessing it? So the next statement I have is element at index this thing in the shopping list is this. So there are two variables. One is what is the element name, which is 2, and whatever is the element in the list is basically going to come next. So this is so that you get familiar with writing code in Python and stuff because next data visualizations is where we'll really use all these formattings. So and stuff, especially when we do NumPy and Matplotlib. Um, so that's where we will start with this thing. And the next part I have is basically how do you delete a particular element? It's a simple command called del, and then you delete it, and then you print out the thing. When you append it, it always appends it to the end of the list. So when I say shopping list dot append mangoes, you can see that the length increases, and you can actually print out the last element in the list. Simple, right? Any questions on these, or is everyone able to execute these basic commands? So you need not write everything right now, but as long as you follow what has been written, or at least if you just write like a simple thing of accessing one element and stuff, because I would want to give like 15-20 minutes for the mini project because that's where you will learn how to like use each of them. So this is just for the practice. Questions? Anyone not able to like work with lists and stuff? You can even send me a chat. I don't think anyone has sent any chats today, but yeah. So there's this other thing where I can take control of your desktop as well. If you're stuck somewhere, I can take a look at your code and then work.
So Sai, like when I do the index, right, from the array, like if I say print two means it'll print the whatever the second array is, right?
Second element is, yes,
Second,
shopping list of 2.
yeah.
No, not second. Sorry, it's 0 based, right? So print 2 would be 0, 1, 2, 3. So 1 second. Let me just print out. So let me run this. So this is a bug I should have. At index, right? So it's 0 based index. So you can see that the index at 2 is milk. So which is 0, 1, 2. So that's why it's milk. And then you can actually print multiple things too. And how do we do that? Yeah, we did that in the yesterday's class where we did colon, right? So when you give 2 to 5, so you can see this line here. When you give, so this statement, what does it say? It says from this index to this index, this is my shopping list. I just, so why do I have 5 here and not 4? So I give shopping list 2 to 5. Why not 4?
Because it starts from zero, right? Like there are
Starts from 0, but also when you give when you give 5, it's exclusive. So it doesn't include fifth. So,
fifth one, yeah.
yeah, 2, 3, and 4. It's the last index is not inclusive. So generally, a lot of people face this bug. Basically, whenever they think, "Oh, I'll print out from 2 to 5," and they'll just give till 5. Please ensure that whenever you are printing till something, you have to give one index extra. So yeah. The lists are pretty simple. It's basically how you add and append and stuff. So is everyone clear with lists? I'll just move on to dictionaries if everyone.
Yep.
Okay. List. Okay. So now we have a list, right? Like, why do we want to use a dictionary when you have a list? Like, what is a dictionary? Like, you come from other program. It's pretty much the same definition, but why use a dictionary? Like, just from a data structure standpoint, right? Like, when would you use dictionaries?
Basically, when you want to store key value pairs.
Exactly. So key value pairs is basically the first thing, because generally whenever you have a key which is unique and then you want to have the name of the and then its value, basically you generally put it as dictionary. It's very readable, it's very easy to access. So the first thing which we like, let's see the syntax of making a dictionary. So when we did a list, the syntax was to use square brackets, right? So you just use the open square bracket and close square bracket, and you had like comma separated values. But when you use a dictionary, you actually give curly braces. And mind you, you can create empty dictionaries also. If you want to create an empty dictionary, you just give open braces and close braces. That's an empty dictionary. But this, like for example, because this is, we'll use this in the mini project. So what we will do here is we will actually create a dictionary of an employee. So you can, let me take a step further. Why don't we add one more field to this? So
Sai, just a second, just before we.
uh-huh.
So see, earlier while we created the list, right?
Mm-hmm.
I've tried out by taking out the brackets. I did not even put any brackets, but still it works. Does
What do you
does
mean?
it have any significance? I mean,
Uh,
I've not put any square brackets, so not the round brackets, right?
so
Nothing. It worked, yeah.
Generally the syntax is to use square bracket because it will do it, but you actually, when you do that, it is basically, is it printing out an element at indexes for you?
Yeah, like zero code, exit code 0.
Yeah. So So
Yeah.
basically, right, like this is how it's readable to the user also. Like when you put square brackets, it's actually tells you that all of them are part of one list. You can
Okay.
omit them also, but because it's so that's the thing with Python, right? It's based on the reason why Python is easier to pick up and people with Python find it difficult to go to other languages. It's based on readability. So if you are able to read things which are like this, and then the interpreter is smart enough to figure out that, hey, then we can put everything in this thing. But in general, it is easier to differentiate between like the list and a dictionary is
Yeah.
it's practice to actually put these braces. So nothing, if it is working without the, I never tried without a square brackets, but if it's working, then it is well and good. But I would recommend, because Python is a language which is based on understanding between all the open source developers, because indentation, the reason why they removed even the braces is because a lot of times you have errors where you don't forget to close the brace, or like some just one brace here and there. So people are like, okay, if anyway you're putting braces and you're putting indentation, why have these braces? So it's something which everyone has agreed upon, the standard, this thing, and that's how we've done this.
Okay.
But for dictionaries also, like you can basically, the norm is to use curly braces. So when you do curly braces, you, as someone pointed out, we have a key value pair. So I think maybe if I do this, it'll be more clear. But you don't do this in this thing because it'll take it as a new line. But you see, I have three values in my dictionary. When do I use a dictionary? Right? When I have an information about, like in my case, or the project which you will write is about an employee management system, right? So what we will do here is, uh, like, what are the properties of an employee in your company, right? One is the employee name, their age, their qualification. Let's add one more bracket, and one more feature, and say his salary. So I won't do that here. That you will be doing it, and you give, open the curly braces, and in quotes you give. So mind you, the key can only be like immutable data types. So immutable data types are like strings or numbers. You cannot have variable data types in your key. Like you can give employee name, colon, and whatever his name is, comma. That's the first property. Second property is his age. So you will give his age. Third property is his qualification. You will add a fourth property, which is called, which is the salary of that particular employee. So, and so let's quickly create a dictionary. So for dictionary, again, you will create another, everyone comfortable with creating new files in a project, right? You say new Python file. Don't do file because then it will not know the extension. New Python file, give it a name saying dictionary.py, and then let's start a small dictionary function. So this dictionary, what we will do is, I created something called as dict. So let me write this along with you. So I just created one employee structure in this thing, one employee dictionary. So in that I have employee name. I put John. His age is 30. His qualification is BTech. Let me add one more parameter here. I'll say his salary, and let's say everything is in his salary. So you actually add that parameter here.
Sai, when we create a new file, does it always have to be .py, or we can save it as, I mean, text file?
No, because .py extension is recognized as a Python file. You
Okay,
can
well,
actually,
so
yeah. So because that's how scripting. You remember, there was a thing in Python called create associations with .py. When you install PyCharm, someone asked me also that question: should we check create associations? So it's always better to, like, it should be .py. That's when it'll, the interpreter will understand, or the interpreter will understand that it's a Python extension.
okay.
So you can then say, or you can create another field called salary, and let's say salary is 80,000. Some white space. Oh, sorry. To give a space.
So I have one more question. There's a
Yeah.
separate, when I right click on the um, files, right? Like there's a separate thing called dictionary, create dictionary.
When you right click on the project.
Oh, okay. No, it's not. It's in the new directory. I'm sorry.
Oh, okay.
1 second. Sorry.
Does anyone else has a question on like why do we need dictionary? Dictionary is a easier way of storing information of one particular entity. Like for example, an employee, you want to have all his information in one data structure. We actually create a dictionary. Let's say even school students, right? Every school student has a name. He's in a particular grade. He has certain things. So we create a dictionary. So let's say if I have a class and I want to maintain all the information of all the students in the class, what are the what data structures would you use for that? Let's say I have like 10 students in the class, right? And I want to store all the information of all the 10 students. What would you do?
Like first name, last name.
Yeah, but
And,
like an
so
array or something.
exactly. So right now we are not using arrays, but we will use list because that's very popular. So what we will do is instead of creating, so we will create a dictionary for every student, and then we'll put all the dictionaries in a list. Is that clear? So basically, dictionary is a sub data structure. So you create a dictionary for each individual student, and that dictionary will have his name, his class, and his qualification or something. But if I want it for all the 10, as Deepika said, like as I said before, right? In Python, we use lists generally more this thing. If you want to use arrays, we use NumPy arrays. But in general, if you're not using any packages, we will stick to like lists. Is that clear? Any questions on that? Okay, let me just finish off with dictionaries, and then I'll probably like code a small example for you so that it'll be more easy. So once you create a dictionary, so what is this doing? It is creating one object called dict, and then that dict will actually have 1, 2, 3 parameters. In our case, it'll have 4 parameters, which is salary also. Once you have this dictionary created, let's say I want to only access one element in that particular dictionary. How do I do it? It's like calling dict with that key name. So here, what is the key? Employee name is the key. Its value is John. And then next one, age is the key. Its value is 30. Next one, qualification is the key. Its value is BTech. So if I want to access the value of one particular key, I will just say dict of that particular key name, and it will give you what the value is. So here is my last statement, which I said. If we want to have multiple dictionaries together, we will put them into a list. So let us start with this. Is that thing clear, or any questions on that? Like when I say key value pair, everyone understands why we are creating a dictionary, right? So a dictionary is used to store key value pairs. And whenever you have an object, like for example, I'm a student, and each student has certain parameters like name, last name, which grade he is in, or gender and stuff. So when you have these things, these are the keys of that particular student. Like each of them has a property. So you'll make a key value pair and put them into a dictionary. And then the way you access the dictionary is by saying, like as I told you here, right? Like if you want to access the name of someone, you will just say dict and that particular key. So dict of that particular key. So everyone program this first 3 lines, then maybe it'll be clear and run it. So all I'm doing in here is I'm creating a dictionary. Again, firstly, how do you create a dictionary? You create by creating this curly braces. So in curly braces, and you actually give it a key name, semicolon, space, and then you give the value. And then you can keep on adding different number of key value pairs. Once you create this, all this is stored in this dictionary. So now if you want to access each individual values, then you will actually say dict of that particular name. Like if I want, now I want to print out, let's say what the salary is, right? So I'll say print salary. And how do I access the salary of that particular person is basically by saying dict of. So if you don't have that particular key name in it, it'll throw an exception. That's a very good point for us to do exception handling next. Oh, I purposefully wanted to show you one thing. So here we have created, so we have created 4 values, right? Employee name, age, qualification, and salary. I purposefully wanted to print out something called dict of that particular and say org, but we don't have org as the key. So then it will throw you an error saying, hey, this particular key does not exist. So let's take 5 minutes to write this and sink in this concept of like when to use dictionary and how do we populate key value pairs.
So Sai, like it's basically like dict is like it's again kind of a key value pair created by us, right? Like
Yes.
does
So
not have
dict,
any
you can use anything. I use the word dict, but I can say dictionary. This is just a variable name, dictionary one.
variable name, variable, right?
Yeah. And then here, and then I have to change everything. I just use, so that's the thing here. You need not mention that this is a dictionary. You can
Right.
actually say that, because the interpreter,
Some
that's what,
table name. It's
yeah,
like some table name.
you can say table one, right? You can even say table. It's just a variable name. So you just use that variable name to create it. That's why a lot of people prefer Python is they need not say, hey, this is a dictionary. Like if you're using like Java or C Sharp, you have to say what type of variable, right? Or else the compiler will not know. In this case, the interpreter will interpret this. Hey, he'll see, oh, it's a curly brace. Oh, there are key value pairs. Oh, then it's a dictionary. So the user need not even specify that. So this is just a variable name. So you just
So,
start.
can we also? I mean, is there a where we can make one of these key value pair as a key by itself? Like like for example, there's no point in printing salary of just the salary because it's an unknown thing, right? If I want to just find out the salary of John,
Okay.
imagine I've got multiple tables here.
Yes. So you will take that particular table name and say salary of that particular John. So when you say like in the next case, let's say you say, instead of the saying this, I'll say employee one, right?
Okay.
And then you can just say employee one's salary. It'll give me is this because I use dict, was that confusing? So you can change it to employee one, like that's just a name. So,
No, that was not confusing to me. I was just checking. We might have like for example, if it same thing is nothing but a table, right? Like in
yes.
real world.
No, but I think the confusion is a table can contain like different things. Here, dictionary contains one specific person's qualities.
Okay.
So when
It's
you're
one.
thinking of a table, you're thinking, oh, it might have like 10, 15 people. But no, dictionary is for one particular person.
Okay.
So it'll be more clear when we do that project. So that project actually, the project which we'll do now is actually exactly one of the questions is that I want to print out the salary of one person. How will we do it? We will do that step by step now.
Okay.
Let's just
Okay.
understand dictionary for now, and then see how do you populate dictionaries? How do you create a bunch of dictionaries together? And how do we append it? How do we delete it? How do we read things from the file? So all of this will be tied together. But just bear with me for now. So we'll just do dictionaries, and then we'll tie everything together. Is this clear? Did everyone write this? Is anyone having any issues with this? And just as how we are going to, like how we did delete, you can always use del command to delete any particular key of that particular dictionary. Like for example, if I don't want to have an employee name, or if I don't want to have an employee salary, I'll just say I want to delete Let's keep the name. I'll delete the salary of that particular person. So now you won't have the word salary. So now if I actually say salary here, I'll get an error. So when I run this, see, it will say, hey, this particular type, employee age, employee salary. Oh, I said Dick, that's why. Let me change it to employee. So this is just a name. So you can actually name it anything. So I just did employee 1. I'll just say age. And then I'll say, so if I print out salary, it won't exist. So it should give me an error because I just deleted salary from that particular dictionary. The way you delete it is called del. And then there is another thing called clear. So when you use dict.clear, it will clear all the fields as well. So let me run this. So you say salary, it says, oh, okay, key error. Oh, where is, oh, sorry. A key error because I've deleted salary out of this. Is this example clear? Is anyone having any questions on this? Meher, are you still using scripts or are you using PyCharm?
I'm back on the PyCharm right now.
Oh, okay, cool. Because if you're using scripts, I was actually thinking of showing some. How do you debug in the scripts? Like you generally use print, you use Emacs or something with.
Yeah, I don't remember exactly right now. I'm on the PyCharm ID right now, so.
Okay. Yeah, I mean for this course, we'll just use PyCharm because we are dealing with a lot of visualization.
Yeah.
Right.
Yeah, I'm on a different laptop right now, so that's why I
Yeah,
use PyCharm ID.
No worries. And like this is just the basic steps, right? Because once you have this, the next you will really appreciate the whole exercise you're doing when you're doing data visualization. Because at the end, when you actually plot different things, especially when you the snowfall example, you will be plotting violin plots, you'll be plotting like box plots.
Okay.
And then that's when you will see all these concepts coming together and
all right.
This thing. Okay, is that is everyone clear with that?
Yeah.
So now, actually, I'll repeat the same question which I actually asked you guys. Now, let's say if I have, let's say I have 5 employees, and I want to store all their information. How would we do it? So there are 5 employees. Each employee has a name, age, salary, and
so it's basically like what earlier Deepika said, arrays, keep them in arrays. Like,
yeah.
Create employee name array and then
exactly.
age.
So we won't, again, as I said, we will use arrays when we do NumPy arrays, but for everything else, we'll use lists in Python. So because array functionality has been developed for the NumPy package, which we have not covered yet. So for now, whenever you think of anything which an array can do, a list can also do that. So what we will do is, so let's do that. Let's quickly create 3 employees just for now. Create, so each employee information will be stored in a dictionary, right? And then when you want to store all the employee information, you'll create a list of all these employees together. Is that clear? So I have the code here for you. So what I'm doing here is I'm creating employee 1, employee 2, employee 3, and each of this is a dictionary. Employee 1 has his name, age, and qualification. Add one more parameter called salary. Employee 2, again, name, age, and qualification. Employee 3 is again name, age, qualification. And then when you want to store all these information in one data structure, you will use a list. And the way you will use a list is square bracket open, employee 1, employee 2, employee 3. And one other cool thing about this thing is basically there's a keys function in a dictionary. So if I want to print out all the things, right, and I don't know what the names are, I'll say employee1 dot keys. It'll print employee name, age, and qualification. And if I say dot values, it'll print out these values. So let's just write this thing, because once we write this, this is part of the module which we'll create. So we'll create small bits of it, and then we'll put everything into one file called mini project. So let's just quickly write. But before you write the code, is that thing clear? Like, firstly, for one employee, how do you store all the information? You create a dictionary, and then you store key value pairs in employee. And now I have 3-4 employees. I put all of them in an array or a list. So we'll create a list, and each list, it's a list of employees, right? So we'll put all of them into a list, and that's how we'll access. The small thing which we are doing here is we are creating 3 employees, and then we'll put them in a list. And then what we'll do is, I did not teach for loops. Maybe I'll just, after this, I'll go into for loops, and then we will print out each employee name and age, qualification, and salary. So once you create this, wait for it. I'll show you how to write the for loop. It's pretty simple. Like, in for loop is basically like, how many, like if you've done C#, it's like for each, right? Like, so you will say for emp in employees, which means you're iterating through the list, and then you will use emp of employee name, age, and qualification. So that way you'll print out employee's name and their values. So this is how you're printing out all the employees' information. Any questions so far? Is this clear? Satya, do you have any questions? I know you're like, I don't know if you're new to Python programming, right?
Yeah, I am, but it's clear.
It's clear, right? So let's write this particular code. Let's create 3 employees. And before that, like, just intuitively, this is the design. Like, if anyone says like, okay, if I have like 10 students, how do I do it? Each student will create a dictionary, and then all the dictionaries will put it in a list. And then we'll iterate through that particular list and display all and display the information. So let me just comment out this thing because I deleted salary. So let me run this. I renamed it to employee. So you can see my output here, right? So I have employee name John, his age, his qualification. Maybe I'll just put like semicolon. Probably display it better. You can ping me or let me know once you finish this thing.
So I have one question.
Yeah.
So this for loop is like working because each of the employees have like the same exact keys, right?
Yes.
Okay. So if each of the dictionaries had different keys, we wouldn't be able to use the for loop.
You won't be able to use. Then you have to use custom printing, because here you're right. Everyone has the same keys.
Mm-hmm.
Then you will be accessing the key if it doesn't exist. Like I showed you how you've deleted salary, right? And then I tried to print, it'll give you an error saying, hey, I don't know this particular key.
Yeah.
You're right, because we put the same structure for all of them. That's why this for loop works.
So the most efficient way would be what then if it's different keys? And
so that I'll just cover in the next thing.
Okay.
So there's something called as multiple args and keyword arguments. When I cover functions, I'll go through that. But it's a good question. That this is the question you need to ask. That's why we will cover like multi-args function and stuff like that. So in that case, you don't need to explicitly mention the key name. You will say for every key value in this, you will print it out. Is that clear?
Yeah.
So are you guys done with this? Let me take a small minute to actually cover for loops here. The for loop, it's not a traditional way in which you actually, a lot of times we write for loops by saying for int I equals 1, int I less than something. So basically in Python, we write for loops in this manner. So you actually have an iterator or a list of things in which, and then for everything in this, you actually iterate it. The key part in the for loop is the semicolon. So you say for, create a temporary variable name in this particular list, you give semicolon, and then you will access this thing. I think I have a slide on loops. That is the next slide. Okay. So yeah, anyway, if we are here, I'll just cover this slide. So these are conditional statements and loops. So I think I covered if else last time because that's how you needed to print out if it's a palindrome or not. But the thing is, you need to put semicolon to know when that, if not true, like here is your condition, right? If some condition, semicolon, do something, else again colon. Sorry, semicolon is like this, colon. So you use colons for indicating the start of the if statement and else statement. And then for loop, and you can also use the keywords and or. So you don't have to use the in this thing you don't need to use ampersand and this thing. You can just use the words keywords and or. We'll do a small exercise on for loops after you finish this. Let me know once everyone is done with this.
So, I mean, we have created 3 employees. Do you want us to do any? Did you ask us to do anything else? Create
We
array also?
created 3 employees and then put them in a list.
Okay.
And then for each employee, I want you to print out this value, their name, age, and qualification. So the way you do that is by iterating through the list. Deepika, do you have any questions?
Yeah, I am getting an error. I
Okay.
just faced that error.
Or maybe we can try sharing of your screen, but let's see if it's a simple error. You paste it in the chat window also.
Yes. I'm getting dict object has no attribute employee name.
Yeah, so the key name has to be exactly the same. So did you
Yeah,
give
I did copy.
firstly, did you so I actually made a mistake. I mean, I changed the name from dict to employee, right? So but then that's not the thing. I think the key value is not right. Is your
Yeah,
employee e small or e capital?
I mean, I copy pasted the same thing.
But here I have e as a capital thing, right?
Yeah, yeah.
The
Once.
name has to be, the key value has to be exactly the same. It's not
It looks like the same. Can I just share my screen with you?
yeah.
How do I share my screen with you?
You should have a thing saying one second. You should have a thing saying remote control, and you can give me access to your screen.
I don't have it.
Or you don't have remote control?
No. Can I just share my code with you?
Yeah, just share the code. No, but I think this one we have to work on because it'll be really useful for us later on.
Okay.
Because for me, when I say remote control and I can give access of my screen to someone.
Okay.
Shrinu, do you know, do you actually see an option?
Oh, request remote control.
Yeah, request remote control. And then I will get that. Yeah, so I go remote control. Requesting remote control of your shared content. If you approve the request, you will have access to the entire shared content and will do it. No, this is
Me accessing
yeah,
your
you
system.
are actually asking me to do. Then maybe let me ask you from here.
Okay, I think I'm controlling your screen now.
Okay. So I have access. I have actually requested to access your screen. Do you see a approval?
I did not get any message.
So it's saying waiting for Deepika to control. You
Okay,
didn't.
let me give up your control. I mean, can you send the
Yeah.
request
One
again?
second, but let me just. Oh, so what you have done is you've actually did emp dot employee name. You're basically accessing a key, right? So it's not dot. It's basically you should put it in like square brackets.
Okay.
So this is not a so again. So this is not a class. So
Okay.
you will only give dot employee name when it's a class and you're accessing objects in the class.
Okay.
This is one object, dictionary object. The way you access the value is by saying square brackets.
Okay. Okay. Like an array, not like a.
Yes, exactly.
Okay.
The dictionary is not a class. It's just like it's a data type
Okay.
in this thing. So I think if you do that, but I really want to figure out how to get access to yours. Can I mean, it'll work with this, but just to figure it out, I'll again actually request remote
Okay.
control,
Yeah.
and then we'll see if I can get access to it.
Okay. I'm still controlling your screen.
Oh, really?
Yeah.
All right. I'll probably figure it out. I'm pretty sure there is a way for me to access your screen. Anyway, you just try that right now, and you will.
Yeah. I'm trying it. I think I should.
Okay. Everyone else has done it, or everyone is good with this particular portion? Any questions on these?
I'm getting an error for some reason too.
Okay. What is your error?
It says indentation error.
Yeah, so that's why indentations are really important. So ensure that so maybe in your for loop you did not give space. So when you're starting a new for loop, you have to give space.
Right, yeah, it
Is
worked.
the indentation error in the for loop?
Yeah, it worked.
Yeah. So
Yeah.
remember this. So this is why Python is a little different, because in other languages spaces don't matter, but Python it matters really a lot because it doesn't have braces, and it doesn't have semicolons to end the statement. So everything depends on where you place your statement. If I don't give the space, it'll not consider this part of this for loop. So it'll finish off for loop here saying, hey, I don't know what else to do. So I need to give a tab, then it'll know that it is part of this for loop. And if I want to print out another statement in the for loop, again, it has to have the same indentation. So I do this, and now I say print hello or something. Now this is part of this for loop. But if I go back here, that is the end of the for loop. So you won't have anything here. So indentation is very important. Indentation means the spaces. Like if anyone has confusion, indentation means the spaces. Like you have to use tab or something.
All right, thank you.
Sure. So can I go forward? So keep this code snippets. We will use everything. So we'll learn file handling. We will learn exception handling. We'll learn Lambda functions. And all these code snippets, and we'll learn functions in Python. Once we actually learn all these 4 things, we'll put all of them together and create a small mini project. Is that clear? So keep these code snippets handy so you can just then copy paste into this new file when you create your mini project. Sheena, do you have any questions?
No, I'm trying to.
Yeah, I see that he doesn't have a microphone. That's why. Anyway. Okay, can I move forward?
So I'm actually getting error, but then yeah, we can move forward. I'll try to solve it myself.
What is the error?
Syntax error is same. I think it should be some spacing error or something.
Indentation. Can you just paste the error in the chat window?
Yeah.
So now you're understanding the why indentation is important and stuff, right? Because if you don't indent properly, then it won't know. Just paste the error in the chat window. If it's really quick, I'll just tell you, or else we'll just move forward.
1 second.
Deepika, is that clear? Why we actually this thing didn't work? Because this is not a class. This is basically an object. Dictionary is a data type, and then the way we access things in the dictionary is by square brackets and give the key value there.
Yeah, thanks. It
Sure, no problem.
worked. Yeah.
Jatin, are you following this thing? I know maybe because you're not writing the code, it might be.
Yeah, I'm following it. Just before, just EMP1 is a dictionary, right?
Yes, EMP1 is the dictionary, and then employees is the list of dictionaries.
And employee name is under single quote or double quote? I cannot see. It's very small.
Single quote. Actually,
This single quote looks like single quote.
Yeah, it looks the same, but let me see.
In the second print state.
Yeah, I just am seeing if I can enlarge my the text font. Anyway, I'll figure it out on how to enlarge. If I do Control plus, most IDEs use Control plus to enlarge this, but it's single quotes.
Oh.
So I sent you the code on the group chat.
The error is it is keys and values, so it's not key and value. So because you're printing out all the keys, right? So it is
yeah.
employee1 dot keys and employee1 dot values. There's an S at the end.
Okay.
All right.
Yeah. Okay. But still, there's an error. But I'll figure that out.
It must be a different error now.
It still says syntax error.
After giving that also.
Yeah.
Is there anything on your screen which says give your desktop control to me?
Asking me? No.
Yeah.
No.
No? Okay. Then it's really strange that when I say remote control, auto accept all requests. Give the mouse and control to this thing.
There's something called share screen, but I don't see a remote control.
So Jatin is requesting to remote control of your shared content. So if I say approve, maybe you can control my screen, right, Jatin?
Yeah, now suppose I can control your screen the same way you can request me and you can
That's
control
what I tried, but when I tried, see now Jatin is controlling your screen. You can control my screen now, but let me go and okay, now I can't do anything. Okay, let me say if I say request control and let me try. Who was having error? Was it Raghav or?
Yeah, it's me.
Raghav, right?
Raghav, yeah.
Okay. So waiting for Raghav to yeah, it seems like only you can control it. Anyway, I'll figure it out. If any one of you know or used this remote control access of Zoom, if you can let me know how I can access your screen, that will be good. If not, I'll probably figure it out by next class. But anyways, are we good, or is there some other syntax error for you?
Yeah, so it's still the syntax that I'm trying to.
Just paste the error, no? Just don't paste the code. Just say what the error it is showing, like from the console window.
Yeah.
Just paste that error.
So invalid syntax it says like.
Yeah, it'll tell you which line or something, right? Invalid syntax somewhere in some line. Oh, yeah, that's the print statement, right? The print is basically not square brackets; it's simple brackets.
Oh, okay.
So your print statement is a function, right? So I think it looks like you're given square brackets.
Yeah.
In print.
Earlier I tried this and later changed. See if it works.
And also you need to give a comma after. So here you have like when you're printing out something. So this is keys in employee object, comma, whatever that value is. Right. So because there are two, this is a object value and this is like a string, right? So two things. After your double quotes, give a comma, and then put them in the simple bracket.
Okay, it works. Thank you.
Yeah, no problem. All right. Going forward, so this is basically what a dictionary is. Loops, basically there are few things in loops. I will give this as an assignment to you because they're pretty simple the way to make loops, because you actually have if statement colon this thing. I've showed you how to do this thing, right? I have showed you how to anyway, the simple for loop is basically by saying for m, like I've shown you here, and then if loop is basically, I think some of you sent me assignments, so you must have you've done the if loop there correctly. The only thing which I want to point out in these loops are you can use and or operations like that. So you can use the keywords. You can say a and b, or you can say like or b. You can, so it's not symbols. So you can do this thing. I will show you my code. I won't let you. I mean, you can write that as an assignment, but I think you'll have more fun when you do the project. There are some statements in control loops. One is break. Break means if it will terminate the loop as soon as some condition is satisfied. There is continue. Continue means like if the condition is satisfied, it won't execute the rest of the loop, but it will continue that. There is Python gives another keyword called pass. Pass is same as continue, but then it'll execute the thing after that thing also. So I think a best way to show it by example. So let's say conditional loop. If you actually if you actually want to write the code, you can write the code when I'm sharing it. But I don't think you need to write the code for if else loops. So for example, like first if loop statement, you say, if I say first if condition semicolon, sorry, not semicolon, colon, print, again, you remember, look at the indentation. Indentation should be the same if you have multiple statements in it. So if x is positive, I say it's a positive number, else it's a negative number. So there are some things like you can even make something called as none, which is a no op. But the way you give and state, like if you want to give two conditions, you will say x double equal to this thing and. So in other languages, you might have like ampersand, right? Like for if else, like you have like ampersand, or you have for or you have this or symbol. But in Python, it's very readable, so they have and or. And then for loop, just go through just like you can just go through my code. Like I'll send this code anyways. So for s in student name, you'll print s. You see that if I have multiple things, I have the same indentation. Like if I want to print out all the values, So, okay, another thing, if you want to write a loop, you use the statement. So when I say for I in range from 5 to 10, that means I is 5, 6, 7, 8, 9, 10. So you use the function called range to actually have, because that's how you have like I less than 10, I plus plus, right? In for loops. In this case, you actually use the command called range, and then you will actually do that. While loop is basically again while something less than this. So let me show you a small example with break and continue. So for example, if you understood break and continue, how many of you have questions on break and continue? Everyone understood what break and continue is? When you break, when I say break, it will not execute anything after that. When I say continue, it won't execute that particular section of the code. Like for example, tell me what is the output of this. The output, I'm saying for I in range 5 to 10, print out the index of I. I'm adding a new value X, I am adding 10. So if X is not equal to 40, continue. If X equal to 40, break. What will be the output of this?
10, 20, 30.
10, 20, 30. Anyone else has different output?
Or X equal to 10, is it?
So
Or
initially,
on top?
so this is just a range, right?
20, 30.
Yeah, actually I can just give 1 and 5. It's just the range, it's
Yeah.
not doing anything. So so that this means that for I equal to 1, and this is again exclusive, right? So I equal to 1, 2, 3, 4. So, and then if I'm saying that if at all, or I can even do like 6, it doesn't matter because I'm breaking here at 40. I think some of you might be confused. So what I'm doing here is I'm saying I in this range. So this is equivalent to saying I equal to 1, 2, 3, and 4. And every time I this thing, I'm adding 10 to X. So for the first iteration, X will be 10. Second iteration, X will be 20. Third iteration, X will be 30. Fourth iteration, X is 40. Now all I'm saying here is if X is 40, it will break. So that means it won't basically, it'll print 40 and it'll stop there. But if it's X not equal to 40, it'll continue. That means it won't go into this particular line. It's pretty simple. I mean, just if you run the code, you will see this thing. But if I actually increase this, it won't print out the word 40 because I've continued it, right? Is that clear, or do you want me to explain break and continue properly? It's again, it's the same as any other language. It's pretty, but I can explain it probably if anyone has questions. Is it clear? I mean, just give me yes or no because I'll.
Yeah, it was pretty clear.
Okay. So just continue. We'll just skip the remainder of the code and it will go forward. Break will stop the. Pass is something which is special to Python. Pass means it's just a no op. Generally, people use pass and write it there because in case if they want to write code again in the future, they'll just use pass. So let's say if I want to write something exclusively when X is 40, right? If I want to write when X is not equal to 40, or if X, I want to write something in the future, I'll just say pass. That means that in the future, I'll come back and revisit this and replace the code here. So pass is an additional keyword which Python has given. I'll give this as an assignment. It'll be more clear to you how to use break, continue, and pass. So is this clear? So I can move forward.
Yeah.
Okay. All right. So this is a simple if-else statements on how we use it. So let us now go into the main topic, which is functions. Exceptions. Okay. So a lot of times in programming we see exceptions, right? Like like for example, just now we saw if we access a key element which does not exist in the dictionary, it gave an exception or an error saying key value not found, or syntax exception. Like we've seen a lot of exceptions, right? So exception handling is the way do you actually handle these kind of exceptions. But before going into that, there are two main ways where people generally handle exceptions. One is basically an assertion, and other is basically a try catch exception. Anyone know what's the difference between an assertion and an exception? Like most of you, when you see the code, they use the word assert, like assert temperature is greater than or equal to 0. How many of you have seen assertions before?
I think that's only to validate the condition, right? Whether it is true or not.
Yes. So generally we use assertions to validate some part of the code. Like you have to have that. Like for example, if I'm dividing something by x, right? I have to have the x greater than 0, not equal to 0. Because if x equal to 0, then you will have an error. So you will say x, assert x is greater. Like in this case, I'll say assert temperature is greater than 0 or x greater than 0. What this does is it's only for your test purposes. Exception handling is done when you don't know how it might fail. Like for example, in like a small example, right? Like right now in our case, which we have done here, let's say I printed out in the dictionaries. Let me go dictionaries. In the dictionary, I printed out something. I deleted the salary and then I printed it out. Like I commented this, but if I print it out, so in this case now, sometimes I might write some code which is you might get a value. Let's say if you're getting a value from a function, and let's say that value doesn't, that key doesn't exist in this, so you'll get an exception. But let's say in some cases, especially in the test code, when you want to test it, you write assertions. The other thing with assertions is in production, assertions won't get fired. It will only get fired in test code. So if you come from like the C# world, you generally have a debug build and a release build. So assertions generally get executed in debug builds. In release, they don't. So assertions are basically when you want to make sure that something is definitely true. Like for example, if I'm writing a small function where I'm dividing by 0, let's say, okay, let me write like, so I have some x and I have a thing which is like 30 divided by x. So now when x is 0, it's an error, right? But if you know that x should not be 0, what you will say is assert x greater than x not equal to 0. X not equal to 0. So what this does is before this statement gets executed, it'll stop and say, hey, your x is not of the right value. So this is generally done by programmers to ensure that the code which they're running does not run into any exceptions. But exception handling is done when you don't have control over what the input is. Like for example, if someone is passing like a different key which is not in your dictionary, so in that case you need to have exception handling, or else your code will crash. So exception handling is nothing but you use a try catch statement. Try, so there's no catch in case of Python. You have try and except. So everyone familiar with try, except, and finally statements? So let me just, I'll just share my whiteboard. One second. So I mean, in case of Python, we generally have there's nothing called as catch, but it is basically, let me share my whiteboard. So in other languages, we have catch, right? So basically what you do is, let's say this is your code. You have your code here. And there are some lines which might throw some exceptions. Like maybe this will throw like divide by 0 or index out of range. Index out of range is another cool thing where you have a list which is of length 5. And then you somehow access, like sixth element, right? Out of range. So there are some cases like this program will, let's say this function takes in index and then it tries to print out that list of that index. And let's say if this list is only of like, let's say there are only 5 elements in this. And sometimes when the index is 6, then this code will throw an index out of range exception. So generally what people do is they protect this code for that cases because they don't want the application to crash. So you have try. The try will protect this code, but you have to handle that exception somehow. So generally what they do is in other languages it's called catch, but in case of Python, you catch that particular exception and then you do nothing or just say printf or print index not valid. So this, what it does is it basically doesn't crash your program, but whenever you get this particular code, it'll go to this, let's say index out of range exception. So here you catch index error, right? Or accept index error. It'll just simply gracefully exit. It'll just print this line and it'll continue with the code. Then there's another thing called finally. So what finally does is finally always gets executed. So irrespective of whether you have an exception or not, so basically, so you get an exception here, it'll go to accept, it'll finish this and it'll go and execute finally. So finally is something like it's generally used for cleanup. So let's say you have certain things. The good programming practice to write finally is to use it for cleanup purposes. So that is try, accept, and then finally. So let's write this a small program for this. So let us create a list. What's this? So let me bring up a small exception handling code. So this is, I've created a shopping list, or I create any list, it's just a variable name. I created A, B, C, D. So I have 5 elements here. So since it's 0 index, it can be 0 to 4. And now I'm trying to access the 5th element in that particular list. So in this case, I'm making I5. Fifth index means 6th element. So this will basically throw an exception, right? Because there are only 5 elements here. So what I do is I accept. So it's similar to catch in other languages. I say accept index error. I say print index not in range. So this is if I know that particular error, I can just say index error. If I don't know that error, I'll catch every exception. I'll say accept exception as E, and then I'll print out that particular message. Finally, I'll say access element completed. So finally will always get executed, irrespective of whether there is an error or not. But since I told you about asserts, so I can obviously give an assert saying index should be less than the length of the list. Is this clear why I'm using this assert? Assert is generally used by programmers to prevent these exceptions. So when I say assert, whenever because it need not execute anything and throw an error if index is greater than the length, right? So that's when we use asserts. But
so it's like basically validation of the input, right?
Validation. So mainly the test code, right? So it's a validation of the input. Whatever you get should make sense. So for that you use an assert, because when assert fails, you don't need to run the rest of your code. But in this case, let me just comment it. I just want to show. Oops. I just wanted to show you like creating an exception.
So your screen also went blank actually.
Oh really? Okay. I think whenever I'm sharing my whiteboard and I'm canceling it. Oh, is this? Can you see it now?
No, I don't know if, with others.
I can see your screen.
Yeah, it's showing that I'm sharing the screen.
Yeah, I can see it too.
Can you see it? Who all, is anyone else who can't see the screen? Anyone not able to see the screen? Okay, I'm assuming everyone can see the screen, right?
No. I'm still not able to see the screen. I mean, I'm able to see the screen. It's blank. It's just
Really? Okay.
Yeah.
Let me stop the share and start the share again. Let me know if you can see it.
Yeah. Now I'm able.
Okay, I restarted it. So just to quickly this thing. So I'm just creating an exception here. I'm creating a list of 5 elements and I'm trying to access the 6th element in the list because index is 5. So the way I deal with exceptions is say I catch, try, and I say if I know what exception it will be, I will say mention that exception name. But if I don't know what exception I want to catch, any exception which it throws, I'll say except this exception, and I typecast it as E, and I print out this is the exception which happened. And I print out finally. Finally will print. Finally is executed every single time. I'm giving you an example of exception handling because we will use it in our mini project. Is this clear as to why, as like how we handle exceptions in general? So in other languages you have try, catch, finally. In Python you have try, except, finally. Finally is generally used for cleaning up the code. Finally means after an exception happens and it is handled, finally will always run in case of Python. But in case of any language, right? So basically you generally look code cleanup is done in the finally segment. Is this example clear? Everyone understands why, how we use finally, right?
Yeah.
Okay. So so another example, if a file doesn't exist, right? You say try open a file. I'm opening it in read mode. So next topic which we'll have is like file handling. So what we will do is, oh, it's Python functions. Okay.
Sai, you said like this exception just get executed only in the debug mode.
No, assert gets executed in debug mode, not exception. Exception is always in all the modes. So asserts are basically when you run test code or debug mode, but not in case of production code. So for example, in this case, so here why don't you guys write this? Why don't you create a IO exception? So try writing this. So you don't have a file name employee, right? So open a file called employee.txt in read mode. So the command for that is you say open the text file and then in read mode. You will get an exception called IO exception. So the way you will handle it is by calling except IO error and you'll say print file not found. And then finally you will say this will always be printed or something of that here. So quickly write this so that you will know how an exception exception. Do you guys want to write it or should I just execute this and should I proceed further? So if you've understood it completely, then no need to write it because just a simple this thing. The thing here is you actually see initially when I tried to access an element which is not present here, it basically tries to say index out of range. And then it went to finally and says access element completed. It always gets printed. In this case, when I try to open a file, it says it'll go here and say IO error and file not found. Is this clear?
Yes, right. We can take this as an assignment.
Yeah, I'll give it as an assignment because this is simple. Like how do you do exception handling and stuff? Because the next topic which we will have, why don't I give a 5-minute break if you guys want? Does anyone need a break or should we continue? Because I want to start with functions and how do you write functions in Python? And then I think Meher asked a question, how do I create generic arguments and stuff? So it is slightly, it's a slightly more involved thing. So do you guys need a 5-minute break or should I continue with?
Yeah, I think you can continue.
Continue?
Yeah.
Okay, let me ask a question the other way around. Anyone who needs a break, please let me know. If not, I'll just continue.
We
All
can
right, Sai,
continue.
we will take a 5 minutes break. Maybe you also need a break too, right? So we'll
Okay.
take, yeah.
So 5 minutes. If people who don't want to take a break can simply use try, except, and finally create your own exceptions. Try to handle those exceptions. It's not mandatory. You can use it for a break, but if you don't want a break, create something called as exception handling and play around with how do you handle exceptions when you get an error, what will happen and stuff like that. So it's 4:45 now. Well, just 5 minutes, 4:50. We'll start with Python functions. Like how do you write new functions? How do you?
Okay.
I am here, by the way, if anyone wants to ask any other questions in anything which we have done so far, I can still do, but we will continue with Python functions at 4:50. Is everyone back? Hello?
Yes, I.
Hey. Okay. I hope everyone is. So I'm just trying to still figure out, like, do you think like having a break in the middle is helpful, or it's if it's easy, then I just continue because I don't need a break as such. But I was just thinking if because you guys are coding and stuff, right? So
I'm back, sir.
okay. All right. So this is a basic intro to exception handling, right? So how do you create an exception? How do you handle an exception? And then what finally does? So this is generally, I mean, you'll use it in regular programming too. So when you have, you protect it with try, except. The difference between, everyone understood what the difference between except exception and accept a particular exception is, right? When you know what exception is going to happen, like for example, in this case, I know IO exception is going to happen. So I use IO exception. But sometimes you don't know what exception is going to occur. So you generally use a generic thing called exception. So if I remove this, section of the code, right? It'll still handle it because it's still a type of exception. We'll say unknown exception. I don't know what exception is happening. And then you can actually handle it.
So it doesn't matter if we include both, right? There may be known exceptions and there could be multiple known exceptions. And
so generally, it's a good practice to include both, because if you know what the exception is, you can give a custom message. So what happens is if IO exception happens, it just executes this, goes to finally and finishes it off. But in case some other exception happens, which is unknown, which is other than IO, if you don't handle it, it'll again crash because you only handled IO exception here. So in general, you give the correct exceptions which you want to handle and give a generic thing. Let's say something else happened, like memory out of memory exception, and I don't specify that here. It'll go into the generic exception. It'll go there and it'll basically handle that. So it's a good programming practice to have what exception you have and then have a generic exception. So that way you'll handle all such error, all the cases.
so, Sai, what is that you have written? Like after try, right? After try, there's a. I'm unable to read that.
Oh, this thing. So after try, I just said open. This is file handling, right? So I tried to open a file which does not exist. So if you see in my code anywhere here, I tried to open a text file called employee3.txt in read mode, but there is no file here. So that's why I know that for sure it'll throw an IO exception. That means that because there is no file, it'll throw input output exception because there is no input. So that's why I said file not found.
So it's FH. What's exactly?
Sorry?
This without try. What's
Yeah.
F?
This is just a variable name, fh, like I can just say file1.
Okay,
I'm just trying to open a file and read the contents of it into file1.
Okay, yeah, because it's so small, it's hard to read that.
Font size.
Could be in the tools.
Yeah, it might be in
If anyone of you figure out like how to increase font size, let me know. Tools, convert to Jupyter Notebook.
Maybe in the help you can take a look.
Yes, let me ask the query. Increase size.
I think you can just click Control and use
I
your
used
mouse.
Control plus plus. It doesn't work.
Are you using a mouse or your trackpad?
No, just a trackpad.
Okay.
Generally, we're looking to Control A. Control plus. Yeah, it still doesn't work. Bonus points to anyone who can figure it out. Let me know.
I think probably it's at the screen share level.
Click Control Alt S.
Control Alt S.
That should open.
Okay, it opened this property editor.
There.
Font.
Yeah, and then you can change the font size.
Font. It's in
font. Yeah, in font. And there you can change the size.
Perfect. Make it 16. Apply. Is this better?
Yep.
Okay. Oh, cool. Thanks, man.
Yeah.
So yeah. So I mean, I'll use the same font size for the. Everyone can see this, right?
Yeah.
Okay. Cool. So let's go into the next topic, which is basically functions, right? So very first thing which we write in any, right now we have just been writing script mode, right? Wherever we actually did string operations and stuff, we never put it in a function. Like, I mean, one basic question, why do we need functions? Like, why can't we write everything in a script? Why do we need to put a function in anything of that sort?
So functions have predefined capabilities which comes with, like, which we can use in our scripting. Like, for example, it could be finding out standard deviation. There could be a function for that.
Okay.
So built-in formulas and stuff.
Exactly.
Functionality.
Any more uses of functions?
Modularity.
Modularity is one. So yeah, I mean, so whenever you want to repeat something together, right? Like for example, I want to print. Print is actually another function, right? So I want to print something, or as someone said, if I want to find the average of something, every single time if we write it in our script, we have to keep repeating it every single time. But mind you, function calls are also very expensive. So if you've done like embedded programming and stuff, whenever you call a function, there's a separate stack which gets created. In memory, the variables are passed by reference or by value. So function calls are expensive. If you're doing something like once or twice, it doesn't make sense to write a function. But if you're writing something, if you want to do something for more than like 20, 30 times, then only you have to write functions. So if you actually work on areas where you want to improve performance of certain code, the minimalistic functions are generally better, because you don't need to transfer, or you don't need to create a new stack. You don't need to transfer these memory locations to that new function and stuff like that. So in fact, if you actually, some of you have done C, there is something called as inlining of a function. It's an interview question which people ask. Why do you need to inline a function? Inline a function means it'll take that function and put it in your code only, so that there is no memory transfer or stack creation and stuff. So functions are generally used when when you want to create packages, right? I create a package and someone needs to use certain functions, yeah, a certain, like for example, average or sum or something of that sort. When you want people to access certain aspects of it, or when you want to repeat it more often instead of putting it in line of the code. Ideally, yes, if you readability is basically what is being saved. Ideally, you can just write that whole code 30 times in your thing, it will be faster. But nowadays, since computational expenses are like, it's computationally not like, since we have so much memory and stuff, no one really cares about having functions. I mean, that's a very minimalistic thing. But there are, in some cases, when you're writing embedded programming, they something called as, I don't want to go into that, but it's something called as loop unrolling and stuff like that. So what that does is basically it inlines a function. Even in C, you have a word called inline. So what it does is, it doesn't need to, because when you're creating a function, you need to actually transfer memory locations. It has to have a local stack. It has to keep track of a lot of things. It takes a computational hit. So generally, if you want like really fast performance, you avoid functions. But in general, like nowadays, that cost is very minimal. So you use functions for repeatability. You need functions for overloading. You need functions for a lot of things. Mainly, yeah, if you want to call something more often, you use functions. And then the way we actually create function in Python is by using the keyword def. So whenever you see the word def, that means that you're defining a new function. So function blocks begins with the keyword def, followed by the function name and parenthesis. So input and output arguments should be placed within the parenthesis. It's like this thing. The code block for every function starts with a colon and is indented. So let me show you a small example. If you go to functions, so Like one example I have is find the average of a list of numbers. So this is just for the syntax, right? How do you start a function? You say def, give the function name, and then put parentheses. And then you basically, again, you see there is no type anywhere in Python. If it was C# or Java, you would actually have to say, is this an array? Is this a string? Is this a list? Is this float? In Python, the interpreter figures it out when you're running the code. So here you will actually take a list of numbers, and then I will ideally this list of numbers is supposed to be uh, uh, so I am actually saying list. So basically you have to pass in a list here. I just take the count of this here. I'm just showing an example how to use assert. So I'm saying, hey, I will only run this operation if the count is greater than 0. Because if you're passing me an empty array, then I don't want to run this thing. So it's a good programming practice to use asserts if you're in test engineering and stuff. And then here I say sum, and then for each value in this thing, I add that to the sum. And I also have a try catch exception. So I say try, I take the average. Why do I need to take the average? Because let's say if I don't have this assert, do you see any potential error which might happen now? I remove this assert.
Say if the list of numbers does not have any numbers in it, sum will be 0, right? 0 by 0.
The count will be 0. Exactly. Sum also will be 0. So you will actually run into divide by a 0 exception. So this is a really good example to actually, put all these things together. You're absolutely right. So by putting assert, I prevented that from happening. So when I'm only going to run this code if it has some values. But as a good programming practice, I put this in try except, so that you can actually see the error which is happening. And then I return this particular thing average. So let's write this function, because we will be writing a lot of functions later on when we are doing support vector machines and stuff, because every algorithm will be written as a function. So just to get you started or familiar with the function, let's write the same function, average of a list of numbers. And then this is how you call it. So create another file, say functions.py, and then we write a basic one. Firstly, syntax. You say def space whatever that function name is, and then you actually give that whatever parameter it is, and then you take the length of it, create the sum of it in a for loop, use try catch exceptions, and then you return the average of that particular function. Is that clear?
Yep.
And then how do you call that function? You actually say average, and then you pass that list of numbers there. And this is how you print. So write this function, how to call it and how to print it. Then there are a lot of interesting thing in Python functions. Meher, I still know the question you asked a few minutes back,
Okay.
so we'll get to that.
Okay, thanks.
But just let's just create a function just so that you're familiar with and how to call it and stuff. So I'll just wait for 5 minutes till everyone writes this. If you're getting any errors or if you're stuck somewhere, you can let me know. So all I'm doing here is taking a list of numbers and I'm creating an average of it and returning it back. Hey Jatin, are you able to, you're still following it, right? I know like it's the first few classes are slightly programming intensive.
Yeah, no, I'm doing it.
Because the thing is, right, like afterwards you won't need that much of programming. It is basically the theory and how you think about data and stuff. But initial few days, I think we need to do a little bit programming, because you'll get, once you write the code, you get the feel of feel of the language. It becomes more like when we go further and make modules. And there is one session in which I'll show you how to write a web service and post some machine learning algorithms on the cloud service. So we'll use Azure ML. I'll give you like how to create account details and stuff. So we'll write a small web service to do a machine learning algorithm on the cloud. So at the end of the day, you can. In fact, I would encourage. Maybe I can do that earlier. I would. I mean, whenever we write these all the programs, I would encourage you to like put them on the cloud, and then you can just call it whenever you want. So you can expose them as web REST endpoints to, I mean, to anyone, or you can just use it as yours.
So all of them are RESTful services, right? Well, connecting with cloud.
Sorry, I didn't get the question.
All of them will be RESTful web services, right?
Yeah, so this is something you're writing it locally, right? But when you actually put it on the thing, it will be a RESTful service. Yes. But that will be so that, I mean, I want to just do that because then you can actually put your algorithms on the cloud, and then you can like it's fun to host these algorithms on the cloud, and you can ask everyone else to like send the data to you in JSON, and you can basically execute the algorithm and give it back.
Okay. So anybody can use your
Anybody
code.
can. You can make it open source, and I don't put it on GitHub also if you want. Like I can teach Git commands too. Like if anyone wants, I can just do a small session on like Git. How do you yeah, it's the
Yeah, that will be helpful because now Git is part of Microsoft anyway.
no, even otherwise also it's basically open source, this thing, right? So we'll do that later on. Let's finish off with everyone done with the function?
Yes.
Is anyone still writing, or any questions on this? So just like when I say like this thing, if you have any questions, do stop, because the main part is for you to understand how to do it. Not, you might write the function, but if you don't understand what is happening, there's no use, right? If any questions or anything on this, do feel free to stop me anytime. Okay, I'm going next step. So that is the basic syntax of writing a function. So you define the function, and then you give the return thing. But Python functions are really okay. This is something which most programmers know. How many of you know, like, understand pass by value and pass by reference? I think everyone must be knowing, right, what pass by value is. So, but just to give a quick overview of what pass by value and pass by reference means. Pass by value means the function will create a local value of that particular thing. So, for example, I have a small code here. So I created a function called change me. This thing will take a list, and it is appending some elements to that list, and it's printing. So here I'm adding 1, 2, 3, 4, 5, 1, 2, 3, 4. And initially I'm initializing a list which is 10, 20, 30. And now I say, I call this function with this particular list. And then after this, I print out my list. So all I'm doing here is I'm creating an object here. I'm passing this object to this function. This function is appending that list, because in list we saw dot append, right? When we did this thing, we did dot append, which will add. Remember I told you dot append mangoes in the shopping list. So that was appending that mangoes to that list. So what will be the output of this? When I print out after passing the function, what will be the output in the function? What will be the output outside the function? Anyone wants
It's
to
same.
Yeah, but what will it be? Will it be 10, 20, 30, 1, 2, 3, 4, or will it just be 10, 20, 30?
Inside of the function, it will be 10, 20, 30. 1, 2, 3, 4. Outside of the function, it'll just be the original 10, 20, 30.
No. So that's exactly the point which I wanted to make. In Python, you always pass by reference. So pass by reference and pass by value means that whenever you are actually passing this value, right? So this thing is not a separate copy. It is the same copy of this particular element. So when you're passing this particular element to this, it is modifying the original value of this particular list. So values inside the function and outside also, it is going to be the same value, because in general, right, when you pass by value, what pass by value means, when you pass my list, this will create a new copy of that particular list, and then it will append to that particular copy. But when you say pass by reference, it means it's taking the same copy of that particular object and it'll append it to it. So in Python, one thing you need to remember is it's always passed by Python. We always pass by reference. It's not passed by value, especially for objects. So is that clear? Everyone understand what pass by value and pass by reference is, right?
Yeah.
Pass by reference means you're passing the reference to that. So any operation which is done on that particular object will be basically will be affected outside of that particular object. So because you're passing the same object to that function. Pass by value means this function will make a copy of that particular this thing, and whatever you change on the copy, it doesn't matter to the original object. This is a standard thing which everyone asks in languages. So pass by reference and pass by value. So when you do pass by value, any changes inside the function will be only limited to that particular function. But when you pass by reference, any change to this particular thing, it's going to operate on the same object. So in Python, it's always passed by reference. Is that clear? You can quickly write a program to check that, but that you can take it as an assignment. But the main thing which I want to cover is, or let me show you this. So you remember this print statement we had? So we were printing out the values of some things and stuff like that, right? But so basically, let's say there is str. Now I will say hello world, and then I will give my name. So there is only one function called print, but I'm actually able to provide it multiple parameters. How do you think Python does that, right? Like, do you think Python has like one particular, so this works, right? If you give this, it'll still work. I can give 10, 20, 30 parameters here, it'll still print everything together. Do you think like Python has implementation for two values, 3 values, 4 values, 5 values, so that people might call like 10 values? Like, you understand my question? Because generally, right, in this case, I'm only passing one object, right? When I'm saying average of list of numbers, it's only one object. If I pass 2 objects, it'll give me an error saying, hey, this function does not exist, because the function signature only takes one object, but I'm passing two objects here. But when you look at print, which is the default of Python, you can pass like 10, 20 objects to it together also. But it'll still print the same value. The only explanation for that is basically Python should be having one implementation with one object, another implementation with 2 objects, another implementation is with 3 objects. Do you think it does that? Or do you think there's a smarter way for it? Did everyone understand the question I'm asking?
Yes, yes.
So when you give print, you can give like multiple arguments. So Python, there's that the unique thing about Python is it can support something called as variable length arguments. So this is like, these 4 are like the main thing about Python functions. So I'll take enough time to go over it because once we actually have these functions, once we are done with this, you should be very comfortable with this. Firstly, there are, we'll cover optional arguments later. There's something called as variable length arguments. So the way Python implements these variable length arguments means You can give it 2 arguments, 10 arguments, 20 arguments. It'll still be able to print it. So the way you write a variable length argument is by giving asterisk sign. So the way Python does it, like it doesn't care how many arguments you have. So everyone write this function. So you write a function, say print multiple I'm just trying to use the same print function. But when you give an asterisk sign in front of it, that means you're telling the function that, hey, the user can pass 10 arguments, 20 arguments, 30 arguments, you should be able to take it. Like in this case, please write this function. So the main thing here is when you want a function to take multiple arguments, you'll give an asterisk in front of it. And once you have an asterisk in front of it, you can just print, it'll be considered as one particular object. So like,
but those arguments need to be of the same variable type?
No, it can be of any variable type. Like for example, the way I'm calling this. So look at this, print with multiple arguments. I'm passing a string, I'm passing a int, I'm passing none, I'm passing different things. So this does not care what kind of argument it is. It just takes all the arguments into one. So one of the main thing with Python's multiple arguments is, if as soon as you put an asterisk in front of it, it will take all the arguments. I can even add here. I can even say, oh, Arya star. How many of you watch Game of Thrones? Anyone fans of Game of Thrones? No? Only me? Okay. So I have a lot of references of Game of Thrones in my code. So in case if people like Game of Thrones. But as you can see, I can keep on increasing this. So whenever you have like different arguments in a thing, you have to use the asterisk symbol. When you use asterisk, it will take as many number of arguments as possible. Is that clear?
Yeah.
Okay. So that is one thing with this thing. And there's something called as optional arguments. But is everyone clear, or anyone has any questions on this?
Yeah.
Okay. Deepika, is it?
Yes, it's clear for me.
Okay. Once in a while, just keep telling me, because because I'm just, so this is the first time I'm doing something like online. I used to do in person before, so I can see other people's faces. So I know they understand or not. But when no one is talking, I'll be like, okay, are they following or not following? So that's why I keep telling, like, any question, anytime, feel free to stop me, because I can't see like how, if you're understanding or not. But anyway, so that is how you use multiple arguments. Then there is something called as optional arguments. Optional arguments like is the same thing for a lot of languages, where you can actually, so I can actually give it, so this thing, and I'll say arg1 equals 10. So this is what an optional argument is. That means if someone provides arg1, it will take it as arg1, or it will just take this as a default value of it. So that's an optional argument. Like if you want to, if someone passes it, it's fine. If doesn't pass also, it'll have some value. So they are optional arguments. But then there's something called as keyword arguments. So this is slightly tricky. So in this case, everyone clear with optional arguments, right? It's there in a lot of languages. You can just give it a default value, and it'll take that value if you don't pass to it. Before I talk about keyword arguments, like in this case, I passed John, actor, none, 32, Game of Thrones, Arya star. It'll be really nice if the print actually can access this particular so it'll be really nice when you're actually passing it to the function, if you can name that particular argument. What I mean by that is, instead of passing John, actor, none, 32, I'll say name equals John, occupation equals actor, age equals 32, title equals villain. So what this does is, these names are given certain keywords. So in regular cases, we can just pass John, actor, none, 32. But there's Python supports something called as keyword arguments. Keyword means that you can actually pass in the keyword, like instead of, because I think Meher, you asked like, can all of them be of the same type or can they be of different types? The reason why they can be of different types is because of these keywords. Because this keyword is saying, hey, this is a name type, and this is name, this is occupation, this is age, this is title. So whenever you want to pass something with keywords, the only caveat is you have to use double asterisks. So when you use double asterisks, it will take all these things into keywords. So you can let me run this code for you. This is maybe slightly confusing. So I'll take in again. I'll explain this again. So when I use one asterisk, it means that you can have any number of arguments when you call it. When I use double asterisks, that means that these are keyword arguments. In keyword arguments, what you can do is you can say, when I'm printing it, I'll say keyword args of occupation. So occupation is here. It will print actor. Keyword args of age, because this is age. Is that clear, or is there any confusion with?
So
yeah.
A quick question. So then maybe a practical application for this would be during data cleaning, correct?
Exactly.
Okay.
In data cleaning, because people need to, because you get data from different features, right? Mm-hmm. So Python is especially used for data science, and the reason for that is because you have these additional things. So let's say when you're taking the Indian liver patients example, right? I'm passing first row should be the name of the person's patient. Second row is their bilirubin count. Third row is their alkaline phosphate count. So I'm going to give like keywords there, so that when you access it, it is very easily understood that the one more advantage of keyword arguments is the order doesn't matter. You see, because it is represented by age, right? Like in general, if you're writing it in other languages, I would have to say, oh, the third argument should be this. So I should say keyword arguments of 3. But now, because I've renamed it, I can access in any order. I can access arguments of age first. I can do occupation next. I can do title next. So I can do control.
So it does the sorting and everything internally, is it?
Yeah. No, it's not sorting anything. What it is doing is it is taking this thing, and then it's as though you're accessing the key value pair, right?
Filtering.
It's just going to filter that particular name. Like for example, here age is there. So it'll just take it'll take everything in one, and like we have done in dictionary, right? We said this of that particular key, it'll print out the value. So it's exactly like key value pairs, but they have implemented this for functions as well.
Okay.
Clear?
I mean, my question is, imagine we are reading this from a file, right? The values are like in millions, like
yes.
name, and whatever
yes.
the entire data set is. So and then if it does not follow any order, like I mean, basically, like how does it search?
Because you are actually saying that the name is this. So let's say you have a file, they have like 10-20 columns. You will say the first column is name, second column is actor, occupation, third column is age. So you are giving the name here. So mind you, this is how you're calling that function. But if you want to implement the function, this is how you are implementing that function. So this is something additional I'm teaching. I mean, it's not required for because most of them, if you're creating libraries in the future, you will actually need to use this if you want to use keyword arguments. Keyword arguments, let me repeat it, is basically when a function actually uses the key, right? Because we saw in dictionary, this is the key, this is the value. So in this case also, functions support key value pairs. So the reason for that is order doesn't matter here. And also when you're printing out, you know exactly what you're printing out. In this case, I'm saying print args. I don't know what you're passing in, right? This doesn't make any sense when you're in this function. I can pass garbage here. I can say 10 float. I can do decimal point. I can do complex number. It'll print it out blindly. But when I'm actually giving the keywords, then you can actually print it out properly. So let me run this example. Maybe it will be more clear. So you see, when I'm printing it in this thing, it is saying John, actor, the name. And in this case, when I actually try to print out keyword arguments, it will actually tell me that this is the name. This is, like in this case, I've printed out only occupation and age. So it says actor and 32. If I don't use keyword arguments, it'll just print out randomly whatever I passed. So in this will give you more control over your data set. That's why we use keyword arguments. So just to recap, functions, basically the way we define functions is very clear, but there are 4 additional properties for Python functions. Optional arguments. Optional arguments means apart from your argument, you can give one additional argument and give it some default value. Second is variable length arguments. The example which I gave you was print. In print, you can give 10 strings, 20 strings, 30 strings. Instead of having each implementation for every function, you will basically put everything in a single asterisk. If you put it in single asterisk, then you can take as many arguments as you want. If you go one step further and if you use double asterisks, that means that you can use keyword arguments. Keyword arguments this is a really good example where you can actually put name equals John, occupation equals actor, age equals 32, title equals Willem. So that is the advantage of keyword arguments. Is that clear?
Yes, sir.
Okay, so let us write this. I think until you write it, maybe it's good to like hear, okay, keyword argument, but we'll forget it next day. So the assignment is basically create a keyword arguments, not assignment, like you're going to do it now. You're going to create a function which takes multiple arguments, and then you'll print out all the multiple arguments. Second, you will take keyword arguments and you will pass in your own keys. Print only the keys which you like. Don't print everything. That is the additional advantage. In this case, when I print args, it'll print everything, what it has. If I want to select, say, hey, I don't want to print out occupation, I can't do it here. Unless I know like it's the third column or fourth column and stuff. In this case, because of keyword arguments, I can pick and choose which one I want to print. So the same assignment, now you'll just print the name and their title. So you won't print out their occupation and age, you'll print their name and title. So write this particular function. So 4 main advantages which Python functions have. 1, optional arguments. 2nd, multiple variable length arguments. 3rd is keyword arguments. So we can actually use like different keywords for the arguments and stuff. So let's quickly write this particular function. And let me know if you're running into any errors. Any questions on these functions, like what these different functions are? Why do we need keyword arguments? Why do we need? This is especially because it's a data science related language. So they've actually made all these functions because when you're handling different kinds of data, when you're getting this data from Hadoop or anywhere, how do you actually segregate them, filter them? So they actually added these arguments to these functions. So it will take time if you're new to Python to get used to, these kind of functions and stuff. But believe me, once you are used to it, like once you understand the syntax and everything, It's very easy to start coding and just a matter of practice. Are you guys done? Still working? Are you done?
Okay, done.
Okay.
Yeah.
I'll just give it a couple of minutes.
Sure.
For others to this thing. So after we do this, I'll introduce our mini project. We'll try to do some part at home, or else we will take the first 15 minutes of the next lecture to go through how we have done that particular project. So, and I'll show you a basic snippet of how do we construct this and stuff. I think one small thing I have to still show is like file handling. And we've covered that like in the previous thing, but I'll just have one more slide on how to open files. So today we have actually done like dictionaries, lists, and then functions. And then we did like strings in this paper. So we using these things, we'll create a, so we've seen how to debug the code in PyCharm, how to do exception handling. In case if you have an exception, how do you handle it? We'll do some file handling, and then using all these concepts, we'll write a small mini project which I'll tell you what it's supposed to do. It's the same employee record thing. Like let's say you're writing a small module for an organization in which you take like information of like 5 to 6 employees in a for loop from the user. You'll create them and keep on appending it into your data structure. And then I want you to fill then there are certain functionalities where I want you to print out only people who have master's degree, and I want you to print out all the names of employees who have salaries above $60,000. So things like that, and then some manipulations and stuff. So we'll do that in the next section. I'm just waiting for everyone to just finish the code. Is everyone done?
Oh yeah.
So the only thing is, if you're using multiple arguments, so multiple arguments without keywords is just one asterisk. Multiple arguments with keywords is two asterisks. That's the only difference. Firstly, the fact that you can do multiple arguments in Python is basically this thing. And then one argument and two arguments is basically what I've showed you here. Do you guys need more time, or are you still like working on it? Are you understanding what different multiple arguments in Python are?
Yeah, I'm working on it, Sai. Like,
Okay.
yeah, I mean, there are some errors, but this time I want to solve it myself.
Okay.
Yeah.
Deepika, how are you doing?
Almost done. Just one more minute.
Okay. Shaker? I don't know if I've heard. Shaker and
Yeah, I'm good, Sai.
you're good? Okay.
Yeah.
So by the way, this whole thing is recorded also, so I'll post it online. So you can just like if you want to refer to this later on, you can just
I am done, Sai.
okay. Okay. Any questions on like how these multiple arguments work? Why do we need multiple arguments or keyword arguments? The advantage of keyword arguments and stuff. Okay, just one slide I have on file handling. So file handling is basically a way in which you basically it's a pretty straightforward. You have like 4 commands. One is you open the file name in read mode, append mode, write mode, and close the file. So that's pretty much what you do in case of files. So when you are doing in read mode, basically you are opening, you can't add anything to the file. When you're opening in append mode, that means whatever you write will get added to the file. But when you're opening it in write mode, it will overwrite everything. So be careful when you use write and append. Append means whatever the file content is there, you will take that content and then add new content to that particular file. But you open it in write mode, it will delete everything which was there in the file previously, and then it will create the file automatically. It will create a new file for you. So these are just the 4 basic commands in the file. This thing. So if this is done, I'm going to like spend like the next 10-15 minutes explaining the mini project which we will be writing. Does anyone need more time, or can I just go into the mini project?
Anna, quick question about the file handling.
Yeah.
If I want to update a value, which mode would I have to use?
Append.
Append.
Yeah, because that's when you want to keep the content, right? You want to keep the content of that particular file. So I have a small example here. I'll send this also. Like this, you need not write, but you can see that reading from a file. So all these concepts will come together. It's always good to do exception handling. So when I'm reading from a file, I'm going to take the file name. I'm going to open that file, and then this is one thing maybe I'll cover in a bit. There's read with yield, which I wanted to actually show you guys later. But okay, let me say write to a file, right? So when you open the file in the write mode, and then you actually go and write whatever you want to it and close it, and you basically put it in try and accept block. There's one really interesting functionality in Python. It's called yield. How many of you have worked on cloud systems or like big data and stuff? Anyone know what yield does? Yield keyword? I think it is part of C# and Java also. Is there anyone who knows what yield does? Yield keyword?
No, Sai, not really.
Okay. So basically, so there is this thing called, okay, I think I'll just go back into dashboard. Share. Let me clear this. Okay, so now you have a database here, right? And let's say this is your big, like your Hadoop or like your big data system. And this is your machine learning algorithm which you're writing here. So this is your computer. And then you're writing your machine learning code here. First thing you need is like, so this is like big data. Let's say there are like 100 million data files here, or like maybe 100 million, like 100 gigs of data, 100 GB data here. So you're writing a machine learning algorithm in which you need to query this data, and then once you get this data, you're going to do some processing on that data. So you process that data, and then after you process the data, you return it back to your. So this is your ML code. Where is it? Okay. So this is your ML code. This is your ML code. Here you're processing your data, and there is some module which actually wants the results. So this module needs your results. So what you have to do here is basically this one queries the data, and then you get back the data, you process it, and you give your result here. So what happens is most of the time when you're querying this data, you have like this 100 gigs, right? So let's say it's a simple thing whether when you're getting this data for each line, let's say your processing is very simple. All you have to do is for each line, you have to add a semicolon. So you have 100 gigs of data. It's like you have each line. I'm just taking a hypothetical scenario in which I have one line, and each line I take, I'm actually going to add a semicolon and then return it to the result here. So generally what happens is someone writes a for loop. In this for loop, he's like, hey, while or while loop, sorry, not a for loop, but someone writes a while loop. So in this while loop, what he says is, as long as I have the data here, fetch me the data, and then I'm going to add semicolon, I'm going to give it back to the result. Does everyone understand this thing, what I'm trying to do here? There is like a lot of data here. We have a while you have this data, get me that line, put semicolon on that line, and then put it back to the result. So what will happen now is it basically becomes a big thing where you actually get the whole data, you wait for processing whole of the data, and then you give it back to the result. So this will actually you have to wait for all this data to come here, and then process all this data and then get the result. But what this yield keyword does is, it's like, hey, why do I need to wait for all the data to be processed? So why can't, let's say if I get one line, I put semicolon, I can give it back here, right? So why can't I do parallel, like, this function will still keep on running, but as soon as I get one line, I'm going to give it to the result. As soon as I get my second line, I'm going to give it the result. Let it keep getting the data as it is, but why should this function keep waiting, right? This function need not wait for all the things to happen and go. So that is what yield keyword does. What yield does is, it in every function which actually has a return type, it will say yield like one row. So let me show you an example here. So if I actually, is this clear? What yield does is, the functionality of yield is, when you're dealing with large data sets, you basically say that as soon as I get one data, I process it, I give it back to this. So if I don't need to wait for all the 100 gigs to come here, process it, and then give it to the result. As long as I can give one data set, as long as I get one line, I'll give it as soon as I keep getting it. So that's what yield does. The functionality of yield is, as soon as I get enough data, I give it back to the function, and rest of the time keep processing it. Don't wait for the whole thing to happen, but as soon as you get like 1-2 lines, just keep giving that to the result as much as possible. Is that clear what yield does? I'll show you in the code how you can write it, but that's pretty much what yield functionality does. Any questions on it? Does it make sense why we need something like this? Because let's say if we don't have yield, what you have to do is you have to keep waiting for the entire data chunk to come here. So your computer needs to have 100 gigs of data, 100 gigs memory, which is free. And second thing is, you have to wait for all the 100 gigs to process and then send the data here. the yield is, so yield functionality will basically help you in two things. One, because as soon as you get 2 lines, you send it back, you don't need that much memory. So you save on memory. And second thing, you save on time. So because this is getting it, so this is like kind of like, processing it as soon as it gets the data. So yield functionality is basically a big data function which actually will help you fasten or like help you save memory. Is that clear?
Yeah.
Okay, so I'll show you how to do that in our code. No questions, right, on this?
I mean, theoretically, yes, we don't have any questions.
Okay, so I'll show you this in the code. Maybe it'll be a little bit more clear. Okay, so what I did in this particular case is I'm saying read from file, but I have this small function here called read with yield. What this does is, instead of, now you can see in here, right? As soon as I get a line in this particular file, I say yield that line. So when I'm reading this file, I'm saying for line in this particular file, I yield the line to the function which is calling it. So what this does, you need not wait for all the files to be read or all the lines to be read. There is, I can just use the keyword called yield, and it'll send that particular line to that particular function. It's simply, instead of returning, so the yield is a replacement for return. Is that clear?
It's a replacement for return, but it will still continues the execution for the next lines, right?
Exactly. It'll, as soon as you get a line, it'll send it, but it'll keep continuing for every line. When you give a return, because it then returns from the function at once, right? Yield actually does partial return. Oh, I get one line, I'll yield. Second line, I'll yield. Third line, but it'll still continue with with all the lines. So that's the advantage. So when you're dealing with large data sets, you can use the keyword yield. So having said that, I'll give you a brief this mini project which we are planning to do. The project is pretty simple. It's taking the code snippets from everything which we did today. The idea is basically you actually will ask the user to input name, age, ID, and salary. So 4 parameters. So you'll ask the user for these 4 things. You'll actually use a like you can use a for loop or a while loop. At least you have to use it, like if you're using for loop, for at least 10 times. So you'll use for I in range 0 to 11. You will keep on, and then you'll use input statement to get the parameters from the user. So you'll ask them for age, employee name, and then you'll ask them age. You'll ask them their title. You'll ask them, title. You'll actually ask them their salary. So this is a user input system. So now these are 4 properties of each employee. What is the best data structure you can think of to store these 4 parameters? We did this today initially, right? Dictionary. So for
dictionary with an array.
Yeah, for each employee, you will actually create a dictionary. And then what you will do is you will actually then maintain this particular all the employees in a list. So you keep asking the user for each of these things. You then create, once you finish all the 10 employees, how you will do that? You'll first create an empty list. So your employee info is empty list. And then you'll create a function called add employee. So once you actually get a new information, you create a new list. You'll pass these parameters to this add employee function, and this add employee will go and append this employee information to the list. Is that clear? It'll create a dictionary and it'll append that. It'll append the dictionary to that particular list. So maybe I'll probably, is that clear, or should I like draw it again? So all I'm saying is, like, you have a for loop from the user. You'll take these 4 entries. You'll take these 4 entries. You'll create a dictionary for it, and then you'll give it to add employee function. Add employee, actually, okay, there is this thing. Maybe I should have talked about. There are something called as global variables and local variables. Let me go back here. So this section, global variables are something which all the functions can access. Local variables are something which only that particular function can access. So you basically, is this clear? Variables inside the function are called local. Variables outside the function are called global. So you will create a global variable for employees, which is the global variable here is the list. And then this list is appended by each function. You'll keep on adding employee to that particular function. And then once you finish all the 10 employees, you will store it in a file. You will write, I'll send you this code snippet. Don't worry about if you're not able to follow. You'll write this to the file. And then once you write it to the file, then I'll give you some tasks. Like, can you print all the employees whose salary is greater than 60,000? Salary greater than 60,000. And then the other thing is all the employees who are below 30 years of age. So that is processing of this thing. So let me tell you the assignment again. So we create a new share. Do the whiteboard. Okay.
I have a question about the Python structure.
Yeah, just one second. Let me just I'll just finish explaining what I need, and then I'll take questions. Okay. So is that okay?
Yeah.
Yeah. So basically, the assignment is you take input from user. In a for loop for 10 times. So what you will do is you'll have a global variable, which is an empty list initially. So list is empty. Then you will write 2 functions. One is add employee function. And then the other function is basically process employee list. What add employee does is it basically, so this is your user input, right? As soon as user sends in a new data, you'll call add employee. Add employee it'll refer to this particular list, and then it'll say list dot append this whatever user input has been there. So once the user finishes 10 entries, you will then write all those 10 entries to the file. So this is part 1. So after this is done, there are 2 assignment questions. One is basically you need to print all employee names whose salary is greater than 60K and then whose age is less than 30. So that is what this one will do. So what this does, sorry, there are no braces in Python. So what this process employee does is it basically takes this. It takes it because this is a global variable, right? So this thing can access this. It basically iterates for each employee in that file. It goes and creates that list of people. Since these are all dictionaries, you'll actually access the keys of that particular dictionary and see if it is greater than 60, you'll print out the name. If his age is less than 30, you'll print out the name. Is this thing clear?
Yeah.
Okay, so I will give you a basic template on how to do this, but this is your assignment. We're going to like build on this particular thing because this will use everything. We have learned about lists. We have learned about dictionaries. We have learned about user inputs. We have learned about loops. And then the one additional question I will give is if you can read the file with yield, that is like a bonus question. So when you're reading the file, right here, when you're processing the, just 1 second. When you're processing the file, you have to read elements from the file. So, but if you can read the file if using yield, like how we do in like big data systems, that's a bonus question. But that would be done at a later stage. But is this thing clear?
Yeah.
Anyone has any? I will send you the code snippets for this. So I'll send you the code snippet of how to add each employee, how to do this. But I want you to think on the problem. So what are you doing? You're taking input from the user. And then the best way to actually store an employee's information is use a dictionary. But if I want to store a lot of employees' information, I will use a list of dictionaries. And then after I finish the list of dictionaries, I'll store it in a file. Next time when I actually ask you to process a particular file, you'll take that file, read the file from the system, go through each dictionary, and then find out employees whose salary is greater than 60,000, print out their names. And then you'll take the age of each employee and then print out the names of people who are less than or equal to 30 years of age. So that is basically like that's the basic, I mean, that's the basic assignment work. I'm going to send you the code snippets for each of the for each module. But any questions on like the assignment or anything till we have discussed so far?
Sai, I would like to understand more about the yield keyword. Maybe I'll connect with you offline.
Okay.
Yeah.
So yeah, we can do that. But for now, like the snippet is pretty simple. When you say yield with yield,
Yeah.
yield, you'll just take the file and you say for line in file, and you'll yield that particular thing.
Yeah.
But this is the basic template. I'll send this template to you guys. It will show you how to read from a file, write from a file. But is the project clear? Like, is the whole working of what we are supposed to do?
Yeah.
Okay. So I will send these things. So so what did you feel like? Do you feel like you've learned too much, or is it less, or should we again repeat some portions of this? We will go through the whole project next time, the first 15 minutes in the next class. So you will see how I've written the code for each of this thing. You will see how those things are like written. We'll go through the assignment also, but I would want you to think on the problems, play around with lists, dictionaries, how to handle files, how to use try catch exceptions and stuff like that.
Sure.
Okay. So we have like some time. So any feedback or anything you feel like you've not followed, or so this is
possibly we have one on-site class like in Bailey or something. So
okay.
we can have some hands-on and you can actually look into it. And
Maybe we can do next Sunday if that's okay. But I don't know how many of you, is everyone in and around Seattle?
I am in the Bay Area.
Oh, you are in the Bay Area. Okay, 2 of you in the Bay Area. But I think we can share using the video and stuff.
Okay.
Let me. We can. I mean, I'll take a video. Like there is a 360-degree camera there, so we can actually share. You can see everything which is happening in the class, and I can share my desktop also. So I'll work on making a class in Bellevue. Is that fine?
Yeah.
Okay. So yeah, that's pretty much it. I think we are at the end of our this thing. Maybe we had to do a little bit more. We will again go through these things next week, like on the project and this thing. But main things which I want you to take home is file handling. How do you handle exceptions? How do you deal with list? How do you deal with dictionary? How do you add things? How do you like process things and stuff? So I'll send you these code snippets after the class.
So yeah, Sai, just one quick question on I know that we are moving forward. Like a few questions on data structures. Like we saw list and arrays, right?
Yeah.
So
List and dictionaries.
yeah, dictionaries. So now, like normally in Java programming, we used to have stacks and hash tables and different things.
Yeah, we have them in Python also, but we won't be using. So basically, in data processing, we generally use arrays, matrices. That's the main things which we use. All operations are arrays. So there's something called as data frames, which
Okay.
I'll cover next week. So there's a package called pandas. So if you're aware, so pandas actually covers data frames and all operations in the data frames. So just to know how to call those things and stuff. This is just an intro to Python.
Right.
But yeah, you have all the thing, hash sets, you have all stacks, queues, and everything also in Python.
So we won't be using because the other data structures metrics will support the.
Yes, the other data, especially matrix operations, will support everything which we need for. So I'm only teaching the stuff which we need for data science. I'm not going into like the whole of Python.
Okay. Right.
So we just started with the basic data structures, and this project will combine everything what we have learned into one. So once you finish this project, you will be able to like add. I mean, so if you actually look at this, I've even used optional. So you can play around more also. I've used optional arguments for this particular function. So if you want to actually write a function, instead of taking all this, you can use multiple args like we have written, and then use keyword arguments when you're passing it to the user. Like in this case, right, I'm using add employee name, age, and this thing. So add employee can actually take, instead of taking, like you can pass it like this, or you can do double asterisks and take keyword arguments and stuff. I think it'll take, once you revise the class, once you go through the lecture again, if you see the video and stuff, it'll be more helpful. Like I know it's too much. If you're not like able to follow it right now also, it's no problem, because we'll again cover it in next class. But this is the basic gist of the extent we'll learn Python. Next, we will just use packages, call data frames, matrices, and arrays. Those will be our next class. Is that clear?
So from the functions perspective, there's 4 types of functions, right?
Yes, only 4 types of functions, like functions which can take keyword arguments, multiple arguments, optional arguments. This is an optional argument. Like if you don't have title also, it's fine, because it'll by default write the title as a SDE. But if you want to override the title, you can pass in an exclusive title, say data scientist.
And one final question, excuse me. So I mean, like print is a function by itself, right? Like range is a function by itself.
Yeah, those are by default inbuilt Python functions. These are your custom Python functions, but those are inbuilt Python functions.
So from the IDE, can I find out all where I mean a kind of a list of functions which PyCharm supports or has?
You can actually do that in so if you go to python.org, they have like the documentation.
Okay.
For Python. So they have all the functions listed there. So if you remember when we installed like Jupyter and stuff like that, where is it getting from? It is actually getting from the Python libraries which are available. So PyCharm is actually connected to that particular web server where Python is. So you will basically get.
Okay, sorry. Yeah.
Okay. I think it's we've had like good 3-hour discussion. We'll follow up again on Wednesday. And I'll send all my presentation and these code snippets. So even if you're not coding, try to run the code snippets and breakpoints and understand what the code is doing. If you're not if you're not writing the code from the scratch, because that will be useful. Okay.
All right. Thank you.
All right. Thank you. And just one quick thing. I think they Pramya, they asked me to mention those who have not registered, Like I don't know like who has or who's not, but they asked me to just remind you once to register further, because we wanted to do these 2 classes to see if you're like following, or is there any other things which you have any like doubts or hesitations. But after that, like I think from next class, I think they're going to be like strict about like who have registered and not. I mean, I just have to pass that message. For me, I don't really care, but I thought I should tell you guys that.
Okay.
Okay. All right. Then I'll send you the presentations and this thing. So shoot me email. So generally I respond like in the mornings. Evenings are generally I'm busy with work, but early mornings I generally check my email if you have any questions and stuff. So let me know.
Right.
Okay. All
Yeah.
right. All right,
Thank
guys.
you.
Have a nice day. And yeah, I'll send you mostly by tonight. I'll send you everything.
Okay.
Okay. Cool.
Okay,
Thanks.
thanks, guys. Have a good week.
Thanks. Bye.